Venus, a virtual double of Earth in size and mass, orbiting just sunward of us, is wrapped in swirling cloud cover. But Venus, like many a goddess, is best appreciated at a distance. Up close, Venus is a nightmare.
We don't entirely understand yet why Venus and the Earth sort of diverged in their evolution. Venus seems to have lost its water and cooked up the atmosphere into this runaway greenhouse state dominated by carbon dioxide, and we wound up with this kind of hothouse effect.
The atmosphere that you would feel on your shoulders is about 90 times greater than the atmosphere that weighs us down here on the surface of the Earth.
Heat, pressure, and a strange geologic history left a very odd surface on planet Venus, revealed here in radar images taken by the Magellan spacecraft.
This is Venus, and the surface of Venus has many volcanoes. They're not active, at least we have not been able to detect any activity. Not much was known about Venus and its surface before the Magellan mission went there in the early 90s. Magellan found many volcanic features, including some rather peculiar structures that we call coronas, and some very long lava flows, the longest seen in the solar system.
Venus is geologically active, or at least it has been much more recently than planets like Mercury or our own moon.
Venus has had a lot of activity that erased craters in the past, but what we noticed about this crater population on Venus was that almost all of the craters were in very good condition. They were pristine. We didn't see a lot that were half buried by volcanoes or were riddled with faults. So what we think happened on Venus was it went through an active period until about 1 billion years ago, and that was followed by a quiet period, which the planet is still in, when it started reaccumulating these impacts.
As you can see, both here on the globe and in the image behind me, volcanism is a very important geologic process on the surface of this planet.
Venus has its own style of tectonic resurfacing. On the Earth, the plates form, they drift over the surface of the Earth, cool and subduct. In the case of Venus, it looks like what happens is the planet erupts in a great eruption of basalt and volcanic activity, and then shuts down for maybe a few 100 million years, maybe 1 billion years, and then probably re-erupts in a great spate of activity. So Venus is doing its cooling in time rather than in space, the way Earth does.
And compared to Earth, Venus rotates backwards.
Venus's retrograde rotation probably is a result of a large impact. Probably after a giant impact, it would have been spinning with a day, maybe 10, 20 hours long. Venus has been slowed down by solar tides, and it currently rotates very, very slowly.
With its crushing atmosphere, searing heat, titanic volcanoes, and massive impact history, Venus is nothing short of a living hell.